In this video I'm going to talk to you about right angle trigonometry. So trigonometry will find the unknown angle or unknown length of side in any right angle triangle. So firstly, let's get to grips with a right angle triangle. When we have a right angle triangle, we have an angle theta, and the labelling of the triangle is always around the angle. So if the angle's sitting here, we would label this side the opposite, or O. If the angle's sitting here, this one's the adjacent, or A. Now, the definition of the hypotenuse is that it's the longest side on a right angle triangle, or that it sits opposite the right angle. So we label this the hypotenuse, or H for short. Now there are three trigonometric ratios associated with this right angle triangle, and they're using trigonometric functions called sine, cos and tan, or sine, cosine, cos for short, and tangent, tan for short. Now there's various ways that you may have learned this in the past. If you've done this before, you may have learned the word Sohcahtoa. I write Sohcahtoa particularly up down like this because it introduces the three ratios within their separate triangles and allows us to reorganize them nicely. So within this first word, Sohcahtoa, this is the ratio of sine theta. Sine theta equals the opposite side divided by the hypotenuse side. Now, let's have a look over here. If I have the opposite and I have the hypotenuse of a triangle, I would then go and use the sine ratio to find the unknown angle. Or if I had the angle and I was trying to find either the hypotenuse or the opposite, I would need one of those to be able to use this ratio. The good thing about this triangle is that it can easily be rearranged. So if I write Soc up here, this is the divide line, this is the multiplication line. So I can use a cover-up rule. If I wanted to find the opposite, I would cover up the opposite, which tells me the formula for the opposite is sine of the angle multiplied by the hypotenuse. If I wanted the hypotenuse, I cover up the hypotenuse, and that tells me that the hypotenuse is opposite divided by sine of the angle. And likewise, if I need to find the angle, which is associated with the sine function, I cover up the sine function, and it tells me that sine theta, or sine of the angle, is opposite divided by hypotenuse. I would then need to do the inverse sine function in order for this to be able to calculate the angle. Let's move on to the second triangle, the cosine. We know that cos, or cosine of the angle, is adjacent divided by the hypotenuse. Again, if you were to look at it in this word ka, in the triangle, it helps us to be able to rearrange it. Divide line being here, times line being here. So if I wanted to find the adjacent and I had the angle and the hypotenuse, I just simply cover up the A, and it tells me that cos of the angle multiplied by the hypotenuse will give me the adjacent. And this obviously can be rearranged as the sine one was rearranged. Tan can be written in exactly the same way. Let's write tan. So looking up here, tan of the angle requires the opposite and the adjacent. Tan theta equals the opposite divided by the adjacent. Or, within the triangle, it helps us to rearrange. It's toa, the divide line, the multiplication line. So let's suppose I wanted the opposite and I had the angle and I had the adjacent. I cover up the opposite and it tells me to take tan of the angle multiplied by the adjacent, and that will give me the opposite. You need to make sure that you are in degrees mode, or your calculator is in degrees mode, in order for this to work. If it says rad or grad at the top, then you'll need to go into your settings and make sure that you change that.